Hello everyone, welcome back to the channel. So today's LeetCode question 788 rotated digits. It is marked medium on LeetCode and then it has been asked in Google, Uber, Meta, Amazon. So before going to the problem statement, let's see what are rotations that has been defined in the problem. Okay, so when you rotate a number by 180 degree, it is called a rotation. For 0, if you rotate it by 180 degree, you get 0, 1, 1, 8, 8. When you rotate 2, you will get 5. Similarly, the other way around. 6, 9, similarly, other way around. For the numbers 3, 4, 7, there are no valid rotations. So, we have been given a number n, okay, and what we need to do is count the number of good numbers from 1 to n. Cool. Now, what is this good number? So a number is good if all the digits are valid after rotations, means all the digits are contains this, and number changes after rotation. So the number should change after rotation. It should not be the same. Consider 11. So after rotation it will be 11 only. So this is not a good number. Consider we have been given number n equal to 9. I have just listed the number from 1 to 9. Let's see after rotation what we get. So when we rotate 1, we are getting the same value. When we rotate 2, a different value, because we see 2 can be converted to 5. Similarly, 3 will not give us any value, 4 will not give us any value. If we see 5, 5 will be a good number because 5 can be converted to 2. So if we go through the example, we will get 4 good numbers. So the idea is simple. When you are checking any digit, just check if it contains all the valid digits. So digits whose rotation is possible, and digits and the second is at least one changing digits, like so the digit which is basically 2, 5, 6 and 9. So if all the both cases are satisfied, we consider it as a valid digit. So the brute force solution is very simple. What we'll do, we'll just iterate from I equal to 0 to n. For every integer, we will check if this is valid. So in the check function, what we need to do is, we'll just take every digit in that number, check if it is in between 3, 4 or 7. Then if the digit is 3, 4 or 7, just return false. Else we'll check if the digit is between 2, 5, 6 and 8. If it is digit is between this and we don't have 3, 4, 7 in all the digits, we'll just return true. And if it is a good number, we'll just make count plus plus and return the count. I have written the code here. You guys can pause and look at this pseudocode. Okay, consider this. You have been given n equal to 12. Okay, and you have to check from all the good numbers from 1 to 12. When you are making the decision for 12, in the previous solution, what we are doing is we are breaking 1 and 2 and checking if the digits are valid. But you see, when you have iterated from 1 to 12, you have already calculated 1 and 2, right? Similarly here, 1, 1, 2, we can break this as 1, 1 and 2, then we will be checking if the digits are valid. But you can break this as this, 1 and 12. When you are iterating from 1 to 1, 1, 1, 2, you have already calculated 1 and 12. Are these valid digits or not? So this hence repeating subproblems, and when we have repeating subproblems, we think dynamic programming. So we have discussed that we will be using a DP array, right? So let's see what a DP of ith index represent. So we will be storing the values 0, 1 and 2. So 0 represent that there is a digit in the DP, there is a digit in the number which is invalid. So it contains 0, 3, 4 or 7. 1 represent that the digit contains 0, 1, 8, it is a valid, and 2 represent that is a good number. 2, it contains 2, 6, 5, 9. Consider this question example 1, 1, 2. Now 1, 1, 2 can be broken as 1 and 12 because still 1, 1, 1, 1, 2 we will have calculated 1 and 12, right? So here we can check if 1 is valid, is 1, 2 is valid, and from this we can make a decision further that is it a good number or not. Here I have written down more examples. So consider I equal to 12. Now 12 can be broken down as 1 and 2. So we can check DP of 1 and DP of 2. Now if you see, 1 is a valid number. Okay, so we represent 1. 2 is a valid number and it can be swapped, like 2 can be changed to 5. So it is a good number at that. For 2, 3, for DP of 2 will give us 2 because it's a valid number and we can swap 2. For 3, it is not a valid number at all. So we'll just represent it 0. Okay, so combining these two, we'll get a not good answer. Similarly, you can do for this I equal to 11, I equal to 7 to know about this problem more. Okay, let's go through the pseudocode. We are first defining the DP array. Then in the second step, what we are doing, we are just iterating from I equal to 0 to n. Okay, so the base case will be when I is less than 10. So we make a decision for 1, 2, 3, 4, 5, 6, 7, 8, 9. Are those numbers, will those numbers fall in the range where we add dp of I equal to 0, dp of I equal to 1, or dp of I equal to 2? Okay, so if I is 0 or 1 or 8, we'll say that this is a we'll add 1 to it. If it is 2, 5, 6, 9, we'll just make the dp 2 and count plus plus, because 2, 5, 6 and 9, these are all good numbers. We can swap them between, right? Okay, else the numbers are 3, 4 and 7, so we will mark it as 0 only. Okay, the next step will be we have to make the decision from previous competitions, right? So we'll just take a and b. So what a and b represents? Okay, so whenever the number is greater than 10, equal to 10, we can see like we are breaking down it as 1 and 0. Similarly, 1, 1, 2 will be broken down as 1 and 1, 2. Okay, then the a and b represents that are this valid number or not. So after this, we are just checking if a equal to 0, 0 or b equal to 0. Consider this case 1, 3. Here we have 3 as 0. Then this is not a valid number. We are just putting dp of I equal to 0. Second is a equal to 1 and b equal to 1. Consider 11. It will be broken down as 1 and 1. So we get 1 and 1 here. But so we will write dp as 1. Else dp of we will represent it as dp of I equal to 2, and we'll increase the count. Consider this case 1, 1, 2. 1 we can break this as 1 and 1, 2. Here 1 gives us 1 and 1, 2 gives us 2. This is a valid good number. So combination of this gives us a good number. We'll just do count plus plus, and then we'll just return the count. So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD or GenAI, please follow along. The code will be given in the description. Thanks.